The sliding window pattern is one of the most useful patterns to master for LeetCode problem solving. There are two main types. The first type is the fixed window. The second type is the variable window. In the fixed window type, the window size does not change, it just slides across the array. Whereas in the variable window, the window size can shrink and grow to stay valid. In this video, we're going to see an example for the variable window type. We're going to solve question 209, minimum size subarray sum, with this technique. Given an array of positive integers, nums, and a positive integer target, return the minimal length of subarray whose sum is greater than or equal to the target. If there is no such array, return 0 instead. For example, we're given a target 7 and a nums array, and this, and then we're going to output the minimal length of subarray whose sum is greater than or equal to this 7. So in this array, the minimal length that is greater or equal to 7 is 4 and 3. So the last two numbers, which sums to 7. And then because this is the minimal length, because there are only two elements in this array, so the subarray length is 2. That's why the output is 2. Here in the second example, the target is 4, and then we have 1, 4, 4. The minimal length that is equal to or greater than 4 is just 4. That's why we have output as 1. In our third example, we have target 11. We have all ones, and then none of them will sum to 11. So there's no minimal lengths that sum to 11. That's why the output is 0. So how do we use the sliding window technique, specifically our variable size sliding window technique, to solve this problem? Let's get to the animation to understand how this works first. Now let's quickly animate to see how this works. Our first example is target is 7 and the nums array is 2, 3, 1, 2, 4, 3. And then the first thing we're going to do is we're going to initialize our left and right pointer, and we're going to expand using the right pointer by 1. So we'll expand it. Now we're going to sum these two, which is 5 less than 7, so we're going to expand more by moving the right pointer by 1. Now the sum is 6. 6 is still less than 7, so we're going to still expand the right part by 1. And then now it's more than 7. So we found our first subarray, which consisted of 4 elements. So that's the first size is 4. And now we're going to shrink the left size by 1. Shrink the left size, and then now it is 6, which is less than 7. So we're going to expand our right part, which now is more than 7. So we found our second subarray, which is still 4 elements. We're going to shrink the left side by 1, and then now it is 6, 7, so which is exactly 7. We have 3 elements in the subarray, which is good, which is a great improvement from the previous one. We're going to now shrink from the left side again. Shrink it, now 6 elements, less than 7, so we're going to expand it using the right side by 1, and then now it is more than 7. So we found our next subarray, which consists of 3 elements. And then we're going to shrink from left side by 1, which now has only 2 elements, but the sum is exactly 7. So this is the minimal length of subarray that we need, which sums to 7. And this is the greatest answer. So the answer is 2 at the end, which is 4 and 3. So this is how we use the varying lengths sliding window technique to solve this problem. Now let's take a look at how the code is written. Let's start from the function signature, which is min subarray length, and we're given the target, which is 7 in our case, and then the nums array. The first thing we're going to do is we're going to initialize a whole bunch of pointers and best insert the variables. The first variable is the length of the array, which is just len nums. The second variable is the pointer, the left pointer, which is pointing to the left side of the array. And then the current sum. This calculates or keeps track of the current sum of the window. And then the best, this is what we're going to report at the end. We're first going to initialize at the infinite, float inf, because we're going to update our answers using the min function. So we're going to first initialize it to the positive infinite. Okay, so and then we're going to use the right pointer to expand our window using the for loop. We're going to use the for loop and then right pointer and then its value using the enumerate function, and we loop through the entire nums array. So right is the index, x is the value of that index. So as we expand it, we're going to add this value to the current sum. We're going to do current sum plus x. So the value is added into the current sum, this window. And then we're going to check if the conditions are met or not. We're going to using the while loop to check the condition. We will check if the current sum is greater than or equal to the target. If it is greater than or equal to the target, we're going to move the left side. So we're going to first update the best. Best is initialized as infinite before. Our current one is right minus left plus 1. So this is our current window size. So we're going to compare the best and our current window size, and we're going to take the minimum of that and then update the best with it. After updating the best with the minimum, we're going to have to shrink from the left side. We're going to in order to shrink it, we first need to remove the leftmost element's value from our current sum, which is the current window. We're going to do current sum minus the nums left, this element, and then we're going to move the left by 1, 2 towards the right. So left plus 1. After all of this, the while loop is done, and then also this for loop is done, we're going to report our final answer. Our final answer is we return 0 if our best is infinite, we haven't found anything, or if we found our best window, we're going to just report the best. So that's the entire logic of this code. So let's just quickly review. So we will first initialize the pointers, our best answer, and then we're going to expand our window to the right. As we expand it, we're going to check the condition, and if the conditions are met, we're going to shrink from left to move to the right. And at the end, we're going to report our final answer. We return 0 if we find nothing, and we return best if we find the best subarray. So that's the entire logic. Hopefully you learned a lot about the variable size sliding window technique. This technique can help you solve quite a few LeetCode problems. In our next video, we're going to continue solving more problems using this specific technique and its variants. So stay tuned. If you like this content, please subscribe and check out other similar videos.